Recording. Good to go.
I'm going to have to look at some of the questions because there's one I don't know on.
Right. Oh, okay, there you go.
I don't know. Apparently it was struggling to go with that.
All right, so let's go ahead and get started with your next homework assignment. Ah, homework, no. No, this one is really easy. This one is really just making sure that you know how to use the tools. The tools in this case means, the make utility program, GCC, both in the sense of compiling and also in the sense of linking. And that's it. Okay, that's basically what this homework assignment is all about. If you don't know, if you do not know those tools by now, it's okay because most people do not know how to use make, until we get to subroutines anyway. But with GCC, it's really just the same as AS, except it is the C compiler instead of the assembler. But for the most part, it does pretty much the same thing. It takes in the source file, it outputs an object file. And then GCC can also be used to link multiple object files. So we'll talk about that today. Well, I'll just go ahead and describe the homework assignment first. Then when we go over the topics, you can probably just link, what you need to do with your homework assignment with stuff that I'm going to do today. I mean, it's really just, about the same thing. This is your program, okay? That's your program, and you don't have to do the entire program in assembly. The only part that I want you to do in assembly is function F. That's the only part you have to comment out from the C program and implement it in assembly. Now this program is pretty easy to deal with because we don't have any local variables or parameters. You can see that X and Y are global variables. This is a include file that will basically type def uint32_t. In most of your classes, I'm pretty sure most of you just use unsigned to mean unsigned integer, and then you use int when you just want to use a regular signed integer. What this is, uint32_t is ensuring the width of the variable. So when you say uint, it means it is unsigned integer. 32 means it is a 32-bit wide integer, and _t is really just a suffix to make sure that we are dealing with a type definition and not a variable. In other words, it's nothing more than saying that x is a 32-bit unsigned integer, and so is y. That's all that it is saying. And then global. Subroutine function G is all it does is to increment x and to increment y. Not much. And this one you don't even have to do in assembly. You can do this one in C and just leave it in the C program. Function F, the next one, would add the content of y to x and then store the result in x, and then it will add 2 to y, and then it will call function G to let function G do its own thing, and then it's done. That's the only subroutine you have to convert into assembly. Do we know how to do that? Yeah, I think we know how to do that. Yeah, the conversion part is not the main essence of this project. I mean, that really is not the essence of this project. Main, we can keep it in C just the same way like it is here. Okay? So let me continue to read the program or read your homework assignment. Create a folder called sub1 for this homework assignment because we'll have multiple homework assignments for subroutines. In it, you need to create a C source file and name it main.c. So main.c basically has just the content that is already listed here. That you just name it main.c as the source file. You also want to have a assembly source file called f.s. Now in this case, the extension is uppercase, not the usual lowercase. The difference between uppercase and lowercase, as far as the tool is concerned, is whether it has to go through CPP or the C preprocessor or not. Okay. Now we are switching gear to use the uppercase S here because from now on, some of our programs will have its own header file. Even though the program is written in assembly, we'll have the concept of a header file. Okay. So that's why we want to use uppercase S so that we can use include files. you also need to create a makefile. And makefile is the name of the file as well. Okay, it's called makefile for this project, so that the default target is the executable that I want to be called main. Okay, so that means when you just say make and then press the enter key on the command line, it automatically brings the executable called main up to date. If you have made any changes to main.c or f.s, it will bring the executable up to date, or if it encounters problems, it will just then stop and tell you that there's a problem. And here's what you need to do. Comment out the definition of function f. So just take this block of code and just comment it out. Okay, I would not delete it, because if you delete it, then you don't know what it used to be before. So I would just go ahead and comment it out. And then convert that particular subroutine into assembly and put that code into the file f.s. Okay. When you're done, create the archive using tar czvf tilde / sub1 submission.tar.gz dash uppercase c / that's / backtick pwd backtick, which is a usual command of creating your archive for submission. And you have to do it when the current working directory is in the subfolder sub1, which is, you guys know this part already. All right. Are there any questions about the homework assignment other than, how do we use the makefile? What do we put into f.s, stuff like that? Yep.
Sounds like you're only converting one particular function to assembly,
Yep.
which means the part we do in assembly has to work with the rest of the C program.
Yep. But right now, there's not a whole lot they have to agree on, right? Right now, the only part they have to agree on is, yes, the subroutine has to be called f. It has to know about variable x, it has to know about variable y, and that's it.
Okay.
Okay?
You're going to show us how to do that, right?
I'm going to show you how to do some of that, without actually doing the homework assignment for you. You guys can do it. Trust me, it's not as difficult as it seems. Yep, go ahead.
So the main the other function that you left it in C, that will be going to the...
Yep. So main is going to call a subroutine that is written in assembly, and then inside the assembly code, you're going to call a subroutine that is written in C again. So your assembly code, or the function that you implement in assembly, is sandwiched between main and G. Yep.
Are there any tricky things, like the last homework?
The last homework?
Got any tricks
There's nothing
this time?
tricky about the last homework.
For you, there was nothing tricky.
I mean, it would be tricky if I just describe in English, what the program is supposed to do. But when it is written in C, I don't think really that's, I don't think anyone can call that tricky, because it should be a translation process and not a creative process. You're not creating a program; you're translating the program from one language to assembly.
Well, I didn't think about putting like a file into it to check if the read function would. Anyway.
Okay.
Anything like that?
Well, not intentionally. Since you asked the question, I have to answer the question, but that's the best I can answer.
Okay.
Not intentionally. All right. So we're going to create a folder here, and we'll just say, pointless. Because I'm going to write some code that is pointless. Okay. So I'll do something similar to the homework assignment. Okay. I cannot make it too close to the homework assignment. So all I can do is to illustrate certain things. So I will just say pointless.c. So this is the C code, and I'm going to do the same thing. Pound include stdint.h. Is that the header file name? I cannot remember. Yep. And then we'll just go ahead and have a prototype called void more pointless. And that's just a prototype. In other words, I'm telling the C compiler and say somebody is going to define a subroutine called more pointless. Okay, I don't know who is going to do it. Maybe I'll do it in this in this source file. Maybe somebody else will define it. But just trust me, somebody's going to define it. And when you call the subroutine more pointless, do not give it any parameters, because it doesn't need any parameters, and do not use any return value, because it does not return any value. That's all it's saying. And then in here, I'm going to say, in the main subroutine, we'll just go ahead and say more pointless, and then we'll return 0. Okay, that's my C program. And just for entertainment, we're going to say in32_t. Well, let's not make it too close to your homework assignment. We'll just say uint16t, and then we'll have variable I and variable j instead. Okay. All right. Now, this part here is not a prototype. This is an actual definition of global variables I and j. In other words, it is not only telling the C compiler and say that, oh, somebody's going to give you a variable called I and it's a 16-bit unsigned integer. It's not just doing that. It's also saying, oh, I'm going to allocate that space right here. Okay, so it is different from that, from that perspective. It is entirely different from this particular line. If you add extern before global variable definitions, it becomes kind of more like a declaration. In other words, I'm just saying that somebody will give me 2 integers, I and j, and they are both 16-bit unsigned integers. But I'm not going to give it to you. I'm not going to allocate the storage. Somebody has already allocated the storage. I'm just telling the C compiler that it does exist. Are we doing okay so far with this concept? So we're going to do it like this one. And I'll just make the program a little bit more entertaining. So I gets a particular value. Let's say this one gets A, B, C, D, and J gets D, E, F, G. Oh, there's no G in hexadecimal, so we'll just go back to 0. All right. So here's my my C code, and then we'll go ahead and write a subroutine more pointless. So more pointless dot uppercase S is going to be my assembly source code. The assembly source code just has to go to the text section because I'm only writing the code, and then it has to define the entry point. Now the entry point has to be the same name as more pointless because that's the name that the C program is referring to. So we'll just say more pointless over here, and it doesn't really do anything. Hence the name more pointless. Yep.
This is probably a dumb question, but how did you did a :E and then did this?
Yeah, the :E means you can change to edit another file. I'm just
Okay.
opening another file to edit.
Thank you.
Yep. So now I have 2 source files. Okay, if you look at the files that I have here, there are 2 source files. All right. So at this point, I can go through this using my command line. So I'll go through it using the command line options. Just hand type all the command line to do it once, and then we'll use a makefile to do this automatically. The first thing is kind of strange because we're going to use GCC to compile and also to assemble the programs. So the first one is -G, -C means I only want to create object files. -G means I want to include debug information. And then we can specify the source file, which is main.c. And it complains because...
Pointless.c, not main.c.
Sorry?
Pointless,
Oh.
not main.
Okay. Pointless.c. So it compiled. And then when you look at the output, it created a .o file, which is called the object file. Okay. So from the source file, GCC as a compiler creates an object file. Is this the first time we see an object file with a .o extension? No, the AS command does the same thing, except it can only deal with assembly language programs. And this one deals with C programs along with some other languages. Okay. So the next one is about the same thing, except this time we give it more pointless uppercase S. As it turns out, GCC can use the extension of the source file to know how to deal with it. If it is .c, it knows it's just a regular C program. If it is .uppercase or lowercase s, it knows it is an assembly language program. So in this case, it will assemble the program and create an object file also. So now we have 2 object files. We have object file 1, which is pointless.o. This is coming from the C program. And then we have object file 2, which is more pointless.o, which comes from the assembly language program. So the next step, none of these files is executable, okay, because an object file is incomplete. It only contains the code that is defined within that source file. So it cannot run, because if I try to create an executable out of pointless, this is what happens. So gcc-o means I want to create an executable file. So let's just say that I want to create the executable called pointless from just pointless.o as the object file. The linker is going to complain and say, can't do this, because we don't know who defines more pointless. And that's because more pointless is contained in more pointless.o, and I did not include it in the link process. In other words, I am using GCC not only as a C compiler, but it is also taking the place of the assembler as well as the linker. You just have to give it different options, then it knows what to do. Are we doing okay so far with just using GCC alone for all the things that we have been doing and then some? Okay, so to fix this problem, I have to say gcc-o and then pointless. So this part is really just naming the executable. It's the same as LD. LD has exactly the same option. -o means what is the name of the executable. We just have to give it one more pointless.o. This time the linker still complains about more pointless. It's not defined. How? Why? Why is this happening to me? It's because I planted this problem to begin with, so I can explain this. When you have labels within an assembly source file, that label is quote-unquote global, but only within that file. So that means more pointless as a label is visible everywhere within this file, but it is not visible outside of this file. In other words, when we create the .o file, it doesn't contain the symbolic definition of more pointless. So now we need to let the assembler and say, I don't just need to know the label from within this source file, I also want someone other than this source file to know what is the definition of the symbol more pointless. Doing that is just using global. So the .global more pointless as a directive is telling the assembler that, and said, when we define more pointless, make sure that everybody else, the linker, also know about this label definition. So we'll go ahead and try to fix this program. Okay. Oh, tag is not working. It's still not working. What is the what's the deal here? Well, I forgot one step, right? I forgot to recompile or reassemble the assembly source code. Okay. Okay, that's easy to do. Reassemble, relink, and everybody is happy now. Okay. Are there any questions about the process? Are there any questions about it is easy to forget to recompile one file before you try to recreate the executable or to run GDB? Yep.
So should we basically split it into three separate functions?
Sorry?
So would we separate the
No, not three. You just have to separate F from the rest with your homework assignment. You can keep G, you can keep main inside the C file. Okay? All right. So now we'll go ahead and debug the program, because now the program is broken up into at least two files. So the question is, does GDB know when to switch from one file to the next, and does it know about the context? Okay, when it is in C, it would use the C way of doing things. When it's in assembly, it will try its best in that case, because assembly source files do not have type information. So let's go ahead and give this a try. We'll list the program, and we'll put a breakpoint on line 9, okay, which is in the C code portion, and then we'll run the program. So now we are just about to execute line 9, single step, and we can print I, because this is in the C portion. It understands that the I is a 16-bit unsigned integer, Okay, that looks fine. Okay, A, B, C, D, is definitely more than 32,000, so that looks reasonable to me. And D, E, F, 0 is going to be a larger number compared to that, and it sure is. Now, it could have printed this one as a negative number if it did not understand this is unsigned int. So this is proof that the debugger uses the debug information in the .o file. When you compile a program from C to .o, it actually contains type information, so the GDB can pick that information up. So when you say print I and print J, it knows how to treat it appropriately. You don't have to tell it this is a 16-bit unsigned integer. It knows it is a 16-bit unsigned integer. Okay, but that's really why we program in C and not in assembly, because C can keep track of a lot of details like that, so that you don't have to take care of the details. Okay, so now we're going to step into more pointless. There are two ways to go line by line. One is called step, and the other one is called next. When you say step, it will trace into a subroutine. When you say next, it will execute a subroutine continuously, but it will stop after the subroutine returns. So in this case, I do want to find out what happens when we step into the subroutine, so I'm using step instead of next. Step. Now this is kind of cool, because it was tracking down in the C file. You can see from the name of the file and also the line number. But when we get into the other source file, it automatically knows that we are switching to the other file, and also it also remember what line we are at that point. So the debugger is pretty useful, because you can actually set breakpoints in any file on any line of that file, as long as it is within that range. In other words, if I want to set a breakpoint back into main, I can actually say put a breakpoint on main.c, nope, this is pointless.c, and then use a colon to specify what line do I want to put a breakpoint on. So in this case, I want to put a breakpoint after line 11. I want to put it on line 12. And it works. So all you have to do is to modify the way you set breakpoints and prefix the breakpoint line number with a file name. Then you can set breakpoints in any file within the executable. Are we doing okay so far? Okay. Now that we're in assembly code, maybe we can try print X again. But it doesn't understand X because we did not say .global X and .global, that it was I and J. Yeah, I and J are still here. Print I, print J, they're still here. So that means you can actually continue to debug your program, even though some of the variables are defined in the C portion, they are still accessible within the assembly portion. Okay. So we can single step. Now within the assembly portion, you can actually do all the usual stuff that we do, like we can look at the stack pointer. We can examine, let's say, the two word 32-bit 32-bit thing that are pointed to by the stack pointer. So there we go. So you can still do all these tricks here, and then you can, if you continue the single step past the return, it will go back to the C code. So you can see that it just switched from more pointless.s line 6 to pointless.c on line 12. So this is how we are going to debug our programs from now on. Okay, this is really just, this homework assignment is basically just making sure that we know how to deal with this, what it means to be compiling and linking, and also how to use the tool that we call the makefile. Okay. So are there any questions regarding this little GDB session? Okay, nothing really, too tricky. It's just that we did not know that GDB is, so powerful that it can deal with, multi-file projects like we just did. Okay, but let's go back and revisit one of the problems that we encountered a little bit earlier. I forgot to recompile a file and then reran the executable and then try to relink, and it didn't work. So that means, whenever I relink, I really need to remember to recompile first, and that's kind of tedious, especially when your project has 2,000 files, right? And it gets even worse when your project has header files, the .h files, because when you have .h files, even if you don't change the .c or CPP files, the actual code file, if you change the definition of a structure, don't you think you have to recompile quite a few files? Anything that makes use of the structure definition should be recompiled. If you don't use a tool to help you, how can you remember which ones out of the 2,000 files you have to recompile? Pretty hard. Okay? All right, so the next topic, we are switching gear and talk about the makefile at this point. The makefile, I'm just going to create my makefile here. The first version of my makefile is going to be very simple, to the point, but also very, very brittle. Okay? When I say it's brittle, what I mean is if I change any aspect of this program, if I want to include one additional source file, the makefile has to be adjusted in major ways. Okay? So the general way to specify a rule in a makefile, a makefile basically just has a whole bunch of rules. Each rule consists of 3 components. Well, one of those or 2 of those are optional. So I'll just create one rule first. So in this case here, my first rule is this. Pointless is my target. Okay, I'm going to create a file named pointless. Okay, and that has to be on the left-hand side with no space in front of it. And then I use a colon to separate the target from what we call the dependency list. So the other component on the right-hand side is called the dependency list. It tells me what do I need in order to create pointless. Well, in this case, we need pointless.o, which is the object file from pointless.c, and also more pointless.o, which is the object file that we created from more pointless.uppercase s. Are we doing okay so far? So this is called dependency list. This is what we are trying to make, and this is what these are the ingredients. Okay, we need those ingredients in order to make pointless. Are we doing okay so far? The next line, yep, go ahead.
Really quickly, what's the extension of makefile, if it has any?
Makefile has no extension. Just makefile is the name of the file.
So no .c or something?
Nope. All right. So on the next line, starting with a tab character. Now this part is important. You have to precede this line with a tab character. This is the command that I need to type in order to go from the dependency list to the target. In other words, given the dependency list, how are we creating the target? Well, we can just type the whole thing. gcc-o pointless, and the components, well, I forgot about the -g, so we'll specify the -g here. And then the component would be pointless.o and more pointless.o. You guys remember that I typed this command by hand when I recompiled and when I linked manually, and we can use the same command here. All right. Well, then we have a question. Okay, let's say we save the makefile, and then we say make. Well, let's touch on the source file. This is the other trick you can do. Is when you say touch star.c and star.uppercase s, it's going to it will change the last modification timestamp of these files to the current time. Okay. So once I do that, I can do an ls-l, and you can see the source file now. This one has a time of 2:29, and the other one has a time of 2:29 as well. But when you look at the object files, they are 1 minute behind, and when you look at the executable, it is also 1 minute behind. So that means the target is now out of date. The question is, do you think make is going to do the right thing? Actually, it does. It does, because make already understands certain things that you don't have to specify. In other words, okay, let me try to explain that part. We never really said how to create a .o from a .c. But make understands that automatically, and that's why it worked. However, there are certain problems with this approach. When you look at how make is compiling the object files, it did not include a -g option. In other words, these object files do not include the debug information. I cannot use it for debugging purposes. Okay. And there's one additional problem. The additional problem is when we have header files, this is not going to work out so well. Okay, so let's go ahead and create a header file just so that we can, I can demonstrate why this approach is not sufficient. So I'm going to go to pointless and then go include pointless.h, which is my header file, and then I switch to pointless.h, and just put some content here. Okay, that's a oops, that part is not needed, and if just ends. Okay, something like that. That's a pretty typical header file, in industry. What it means is, if this macro is not defined, go ahead and execute everything, or go ahead and process everything up to the #n if matching this #n not defined. Ndef means not defined. So this way I can actually include this file multiple times, and it's not going to cause problems. In other words, I can even put a struct definition here. I can say struct x, int I, int j, like so. And you already know that we can only have one definition like this. We cannot define struct x twice, because the name x is already used, and the second definition will fail. But when you look back into pointless.c, I can actually do this, and it's not going to cause problems. Does everybody understand why it's not going to cause problems? The first time I #include, this macro called __pointless_h is not defined yet. Well, since it's not defined, the condition of not defined is true, and it will actually go ahead and process this part of the header file. Okay? But in doing so, it is going to define the macro itself. The very same macro that I was looking for, that was undefined, is now defined. That's the first time of #include. The second time of #include, it will first check, to see whether pointless.h as a macro is defined or not. Well, since it's already defined by the time I #include the second time, the not defined macro is going to return false. So that means it's going to skip everything all the way up to the #n. In other words, it did #include the file, it just skipped processing the majority of the file. So this is a fairly industry standard trick that people use in header files. And the reason is not because crazy people do stuff like this. It's mostly because #include files or header files can also include other header files. So there's no telling whether, if you say #include, a.h, and then you say #include b.h, there's no telling whether, a.h and b.h will eventually try to #include the same common file at some point. Because a.h can #include, c.h, c.h can #include, d.h, and so on. So it's very, very tedious for you to track down, how these #includes works out and make sure that they do not #include the same file. This approach says it doesn't matter. They can #include the same thing in the end. It doesn't cause problems whatsoever. Are we doing okay so far with this approach? Okay. All right. Now, remember what is the whole point of pointless.h?
To show us the problem with the make file.
Exactly. So now, when I say make, it seems to know what to do. I mean, it recompiled, pointless.c into its object file, and then relink everything to create the default target. Seems to work fine. Well, let's go ahead and change the header file. So we'll go ahead and change pointless.h, and I don't even have to do anything significant because any update to the header file should trigger a recompile of the .c file that is including it, right? Even though I'm not using struct x, the preprocessor doesn't understand that. So when I say make says, hey, there's nothing to do, it's up to date. That's because, why do you think that's the case? The default rule is to say that pointless.o depends on pointless.c. It doesn't know anything about pointless.h. dot h. Yep.
If you tried to use struct x in your pointless.c, would you be able to since it's not compiled?
It will just be using the old definition of struct x, and that makes it extremely dangerous.
Was you never compiled .h though?
It did. It did this time. But after I made changes to pointless.h, it did not recompile. It thought everything is up to date already.
Okay.
Yep.
Because it's not, your object file is not dependent upon it right now. There's no rule.
Because the default rule does not specify anything about header files. Okay, the default rule, if you will, there's a default rule saying that pointless.o depends on pointless.c, and then it uses GCC to recompile. But you can see that the dependency only lists the .c file, it doesn't list the .h file. And therefore, when you change the .h file, it doesn't know that the target called pointless.o needs to be updated. No, go ahead.
I was curious if you deleted your object files from the folder, would it still be able to compile everything
Yes.
with just that command?
Yes, if you delete all the object files, it will try to recreate everything.
Okay.
Because without the object file, it cannot even know whether your executable is actually up to date or not. So it will recreate the object files, and then it will relink to create the executable.
How does it? Because if you didn't have the object files in there to begin with, you created a makefile.
Yeah.
How does it know which object files link to which .c files?
Well, I'll explain that later, because there's a thing called a wildcard. So you can actually use wildcards to try to match rules and see how it can create the targets.
So it'll guess which C program you want
It goes
to
through a
use?
list and see whether there's a .c file of the same name, whether there's a .s file of the same name. So it will go through extensions of source files that it knows of and see if any one of those implied rules can apply.
Okay.
But those rules are very dangerous to use because of this problem. Okay, so the proper way to do this is to do it by hand. So when we do it by hand, we say pointless.o depends on pointless.c as well as pointless.h. Okay, so that's the key. And then we can now specify the full command and make sure that we also use the -g option to include the debug information. Okay, for those of you who want to use -wall, which is warn all, it's also a good option when you're dealing with some other classes. In this class, it's not a big deal, but in other classes, this can be a time saver. You can detect problems. And then we can say, pointless.c, and that is a better way to do it. Because this way, when we change pointless.h, it knows that it has to recompile and bring pointless.o up to date. But when pointless.o gets up to date, then it will also trigger the first rule to make sure that the executable is also up to date. Yep.
If you don't have the bottom line with the H, and you try to compile, but you didn't have the object file yet, would it make anything?
Yeah, it will create the object file.
But because you didn't say, it doesn't know about the H, so does it still automatically do it?
Yeah, if you tell it that this is, the first part is really just a trigger. I can even list files that are not even here,
No, I mean,
readme.txt, but as long as I update readme.txt, it will trigger this rule and it will execute a command to bring pointless.o up to date.
I mean, you don't have the pointless.o execute thing in there at all, only making the executable.
Yes, because the .c option means that I want to create object files. So if you don't specify -o, by default, it will create a file with a .o extension already. So, you can do this if you don't want to rely on the internal default. You can always say that, which is fine. But if you don't say that, it will just use a default way of naming the object files.
This is not what I meant.
Okay.
And if you don't have those two lines on the bottom that make the object file at all, and when you try to make the executable, when it automatically do the object file, does it know how to include the H, the .h? Because it's not included up there.
Okay, I think I understand your question. When you comment out these two lines and you say make is going to use the default rule and say that pointless.o only depends on pointless.c. Now, if you did update pointless.c, it will trigger the recompiling. The recompiling will #include the .h file.
I mean, that's only, I'm talking about when there's no object file made yet.
Then it will have to compile it, yes. So if you have no pointless.o in existence, then it will create it anyway. It will have to compile and create the object file.
And that would include the .h too.
The compile process always makes use of the .h file because of the #include in the source file. Okay. All right. So let's double check and make sure that this actually solves the problem, right? So we'll go ahead and say make, and this is actually a leftover from last time, but this time I'll make sure that I touch pointless.h and see whether the make utility program will pick it up, and it did. Okay, so this is better, okay, because now we can, at least it understands the dependency of the .h files, so that when we change the .h files, it also knows how to deal with it. That's very good. All right, and we just need one more explicit rule here, and that one has to do with more pointless. So we'll say more pointless.o depends on more pointless.uppercase s, and I'll just say that that guy also has his own header file, quote-unquote header file. But I'm not going to use .h, I'm going to use .inc for include, and we will assemble the file using pretty much the same options here. Okay, looks pretty much the same.
You forgot the dash before the wall.
Oh, actually the dash wall does not apply to uppercase S file anyway, assembly language files. So I can omit it. It doesn't really matter.
Why do you think that more pointless? The more pointless file. You type more pointless.include.
I'm going to change it so that it has that header file. Because I want to illustrate that we can actually have include files inside when we specify assembly source files. It's the same way. #include, the same way, exact same way. So #include more pointless.inc, because I don't want to use the same extension for C and assembly. And then we'll go ahead and create that file at this point. And what you can do all kinds of stuff. When you have a #include file, anything that goes into a .s file can go into the header file. So typically it includes like symbolic definitions. Okay, it includes symbolic definitions like L1 equals 256. You can just define anything. Okay, doesn't matter. It doesn't matter what you include. And you can also use the same trick. Pound if ndef blah blah blah, and then all the way to ndef. But I'm just going to make this point here, so I'm not going to make any anything that's fancy at this point. So when we say make, it remade the assembly file, that's fine. The thing that I want to test now is if I just touch more pointless.inc, is it going to remake the object file and then remake the executable? And the answer is yes. Okay. So this is better. This is much better than the default built-in rules, because the default built-in rules do not take header files into consideration. Yep.
Just real quick, can you show once again the make file?
Sure. Yep.
Does the order matter?
Yes, the order does not matter except for the first one. The first rule specifies the quote-unquote default target of the whole thing. So when you say make without anything, it understands that we are trying to make pointless as the executable. Now you can also be explicit. You can say make pointless.o, and it will try to do everything it has to do to bring that particular object file up to date. But since your project is really only interested in the executable, that's why we can just say make pointless. But because that really is our default target, so saying just make would do the same thing. Yep.
What does it do if you put in a space in the second line? It just doesn't like it, or is it telling it something?
I do not know. I think it just it doesn't. I think it doesn't understand it.
The syntax of make.
Yeah,
requires-
missing separator. Because it expects a tab to be the separator.
For no reason. Space has no meaning in it. Just make that work.
Yep. Okay. All right. So now this file works now. Okay. But the next question is, I'm going to try to answer questions that some people have in their mind. What is the whole point of an include file in an assembly language program? Right? Yep.
Share preprocessor commands with C code and assembly code.
Yeah, but what is there to be shared?
Symbols, define symbols, function symbols, function headers, types.
But that's automatically shared.
Pound define constants.
Pound define constants can be useful. Yep, yep. Well, we are going to get to structures in this class. Okay. In other words, we are going to write some programs partially in C and partially in assembly that makes use of structs. Okay, in C, which is basically the same as class in C++. Okay. But what I want is for your assembly code to understand the concept of struct, so that you can actually access individual members within a struct pointed to by a pointer. Okay, that part is not too hard. The difficult part is if I change the struct definition in the c.h file, how do I bring the assembly version of the program to also make the appropriate changes so that they are synchronized? That is the big question. And that is a little bit, ahead of. We are going to deal with that, later on. But that's the necessity and why we are setting this up at this point. Okay. All right. So for now, you just have to take my words and understand that sometimes, assembly language programs also need to have pound includes so they can share definitions with other, assembly programs as well as, with C programs. So we'll just kind of, We'll talk about exactly why that is useful when the time comes. Yep.
In the example code you didn't modify the values of I or J. So if I wanted to do that, could I just use move L or add and then I or J as those symbols and that
Yes,
would work?
the labels I and J will be available in your assembly code.
Okay.
Yep. So now we want to take a look at, I moved this module ahead of time. It was down here before, but I think that we can actually move this ahead of time and look at it, from a little bit earlier at this point. Okay, so here we have an example. This stuff looks pretty much the same as what we just did. Okay, basically explaining the basic rules. The tab character is gone. It has to do with how the tool that I use, to create the HTML files from the original source files. So let me see if a better version is better. Let me try this one. This one is better. Okay, it keeps the tab character here. All right. So the next one is going to do something like this. Okay. What is different about this one is I now define quote unquote variables. CXX flags equals to a certain definition. So what that does is it automatically, if you specify the rules to make use of that, then every time you refer to dollar open paren CXX flags close paren, it automatically substitutes the definition of that variable in place. Okay, so that means you only have to define it once, and then you don't have to worry about not remembering to do it again. It's kind of helpful, but I'm not gonna change my make file just for this because there's a whole lot of good stuff coming also. So I'm not gonna have to go through changes after changes after changes. Okay. Yep.
You have to dash O and one of them is something definition.
Sorry.
On the main, go down. The dash O, you have to copy it. So dash O.
Dash O?
Because the flag.
No, this is dash uppercase O, and that's dash O lowercase o.
What's the difference?
Dash uppercase O specifies no optimization because it has no number after that. dash lowercase o specifies the following thing is the name of the output. So they're different.
So if that's the case, the dash small case O and the file name could actually go at the end because all you're looking for is that flag to say what it's going to be called.
These two can both go to the end if you want to.
Okay, I'm just.
I think it can go to the end, but normally we specify the options first, and then specify the actual files, as the last part of the command. All right, so that's that, and then we move on to the subsection. Okay, so this time it looks a little bit different. Okay, what is the change? The change is we define this as a quote-unquote variable, and then we refer to that variable here. Okay, so what this means is main as a target has the following dependency. The dependency is based on the definition of the variable src, okay, which is main.c and array.c. But instead of referring to these files as main.c and array.c, replace the extension .c with the extension .o. So effectively, this is really saying main.o, array.o. Okay, it's a substitution of the extension. Are we doing okay so far with this? No? Okay. What I am trying to do is I want to be able to just change a few definitions at the beginning of the makefile and not have to make any extensive changes in the rest of the makefile. When I have additional source files, I don't want to have to change 20 lines or even, I just want to change one single line and say that, oh, by the way, we also need this source file now. And then I want the makefile to automatically understand that and make all the adjustments accordingly. Okay? So this is what it means, because when I say the source file or src is main.c and array.c, that by itself doesn't really do anything. Okay, I can define src to be anything, even names of files that do not exist. But over here, what I'm doing is I'm saying refer to src, the definition of src, but when the make utility program sees a .c file, change the extension so it becomes a .o file. So that effectively changes main.c, array.c into main.o, array.o, when we specify the dependency of the executable. Question?
So then you could also just not change the .o, and if you wanted the .c's for another declaration, you could use that. Oh.
Yep,
Oh, that's
exactly.
cool. Okay.
It comes in very, very, very handy later on. Yep, question? Okay, so we got that question answered. All right. So this is called a substitution operator. Okay, that's basically it. All right. So now we can look into the dependency part. It's really kind of okay. Let me just look at the makefile again, and I'll let you guys decide whether it is. Don't you think it's really just kind of redundant that I have to retype pointless.o down here? If I specify pointless.c here, I have to retype the same thing here. It's room for error. In other words, you can specify one file here, and you can specify the wrong file here. Make doesn't know that it is wrong. It will just execute the command as you specify. If you specify another source file here, it doesn't care. It will just compile that file. In this case, it will force the output file name to be this file name, and it is happy.
It's happy.
Yeah, but your executable may not be linkable anymore. If it is linkable, you're in bigger trouble. Okay, so so that means we are trying. So this time I'm trying to use something like this. The $caret symbol is referring to the entire dependency list. Okay, so that means $caret means the entire dependency list. Whatever is on the dependency list, stash it here. Okay, which is fine. Okay, that's cool.
Now, is it because you're using the dollar symbol? Because I noticed it's the previous one you're saying mark this place, or is it the dollar symbol specific?
It's the dollar with the caret.
Right. But I mean, I noticed you put the dollar at the first part before you put the source code to replace.
Yeah, that
So
basically
it has to be on.
the dollar symbol tells the makefile and say that this is the beginning of something special, so pay attention and process it. In other words, we are not talking about a file name, we are talking about something that requires attention from the make utility program.
Okay.
It's kind of like when you write PHP code, you know, for those of you who know PHP, how many people know PHP? Ah.
Oh yeah, like when you're at PHP.
Okay, never mind. I was trying to draw from that kind of background, but I guess I won't. Okay. So anything that is not beginning with a dollar sign is interpreted literally.
Okay.
But when you put a dollar sign in front of something, then when you use the dollar sign, the make utility program pays attention and go like, okay, this is instruction for me. I need to do something about this. So in the case of a caret symbol, it means I want to refer to everything in the dependency list. Okay.
Okay. Now, could you use it again on another line further down, and it would just go to that dependency list, or is there a conflict that can arise?
It only applies to this particular rule. So every rule has its own dependency list.
Okay.
So the scope of this symbol is only within its own rule.
Okay.
That's a very good question. All right. But then we also include something that is kind of odd and strange. Okay. This stuff here. Okay. So let's take a look at this stuff and find out what it means. The % symbol means wildcard. This means blah.d depends on blah.c. Okay? That's what it means. This is the command in order to go from a .c file to a .d file. I'm not going to explain this full command. All it does is it uses a particular feature of the C compiler so that it can automatically figure out the dependencies of header files. That's all that I'm going to tell you. Okay?
Oh man, why do you have a big blob? That's just one command line on you throw ECC. Why is there a big blob? That's all my questions.
Well, it's only one single command, but you need to do some post-processing to make it work.
Yeah. That's not how I do it.
Not how you do it? Okay. So this is mysterious. Okay, this is something that we haven't seen before. Okay, so whatever we haven't seen before, we stick it into our make file and see what it does, right? Well, as I keep telling people, software people would make really bad people for bomb squads. Push that button, see what it does. Clip that wire. Oh, okay, that didn't
Combine
work.
these wires, see what they do.
Yeah. Okay, I guess that didn't work. Reset the game. Did you save the game? Oh. All right. So now we have just appended that portion to the make file. Make fill. All right. So now we have this portion here, and I'll just go ahead and put an empty line here, and make sure that we have tab characters in front of everything. And I'm just curious.
One quick, you don't have CXX flags defined in this. Isn't that going to be an issue?
We'll go ahead and define it. Okay, just -G is fine. All right, so that should make it happy. All right. So this time I'm not interested in the default target. I just want to see what pointlist.d looks like. Okay, that's the command that it uses in order to create a file. So we'll go ahead and look at pointlist.d. Oh, it automatically destroys the file because it is not used in any other way. Okay. It doesn't, because I do not refer to the .d file, it just destroys that file automatically. It has to do with this command here, or destroy it, because this exists and it destroys it. It will work better if I actually use something else. work. Okay, so this time it. Oh, okay. I guess did I have a typo before? Anyway, well, this is what it creates. Okay, this is created by that that mumbo jumbo long command that spans over 3 lines. You mean all that mumbo jumbo just for this? What is it? What does it say? Does it look like a makefile rule to you? Yeah, it is a makefile rule, except in this case, we have 2 targets. Okay, we have 2 targets. One target is this one, and the next target is this one. Okay, so what this means is pointless.o as a target depends on these files. Pointless.d as a target also depends on these files. In other words, if I change any one of these 2 files, the make utility program understands that, oh, I better bring this up to date and also bring this one up to date. Are we doing okay so far with this? Okay. Now, how do we bring those files up to date? Well, let's take a look at the make file. This tells me how to bring the .o file up to date, and this one tells me how to bring the .d file up to date. Are we doing okay so far? So we do have methods to bring both files up to date if I make any changes to either file. Okay, well, we better make sure. So if I say make pointless.d again, there should be nothing to do. But if I make some changes, let's say I just touch pointless.h and remake the .e file, oh, it should have recreated the .e file. So the .o. It does know that it has to recompile the .o file, but not the .d file. Doesn't make any sense. The .o file works, but the .d one does not. It thinks it's up to date already. I'll think about this.
Go back to the make file.
It should understand that. Oh, okay, it's because of this part here. It does not specify the .h file. So never mind. It matched this file before it matched the other file. The other file was not used at all. Okay, that was.
So if you touch the .c file, it should do it.
Yes, if I touch the .c file, it should do it. Okay, this was my mistake. Okay, this is specifying a rule. How does make know about this rule? It doesn't. Okay, so that brings us to the next slide. The next slide says the make file can have its own include files. Don't you just like the concept of including? It's like it's everywhere. C programs, C++ programs, assembly programs, even the make file can have its own pound includes, quote unquote pound includes. Yep, go ahead.
Are we supposed to use all of this in our make file?
You're supposed to be patient and wait until we talk about the whole thing, because by the end of this entire thing, we'll have a template, a make file template, where all you have to do is to redefine a few things and everything will just work. Okay, that's the objective. Not only for this class too, you can use the same thing, the template, for all of your other classes. All right. So now we have another make file here, and the most notable change to this make file is this part. Not pound include, it's just include because it's a command. Include $. We have seen the dollar parentheses thing already, but this time I'm changing all the .c to .d files. In other words, if pointless.c is in the file in the name src, then it will include pointless.d. So whatever rule is specified in pointless.d is now a part of the make file. Are we doing okay so far with this? Okay. So let's go ahead and stick this also into our make file. Okay, since we don't know what it does, we'll just go ahead and try it out, right?
See what this button does.
Cat to make file, and then just paste. Control D. All right. All right. So we say make. Okay, no big deal. Okay, but this time we'll go ahead and touch pointless.h again, and then we'll say make pointless.d, and it still says it's up to date.
Well, I mean, the line you just added is still point C to point D. What's it care about point H?
Well, it is supposed to have count included that rule already. So it should understand the .d file depends on the .h file, and as a result, it should have re-triggered that rule and remade it. And the ordering should not have anything to do with it. Yeah, it still says it's up to date. Okay.
Well, I'm glad you're confused too.
All right, so we'll just kind of I'll keep this one in mind, but I will talk about some other stuff here too. In addition to src, now I also define exe. So this one is really just saying the executable depends on all the source files, except you have to change the extension of the source files from .c to .o. Okay, is that okay with you guys? Okay. But tag, my program, our project also has uppercase S files, not only .c files, right? Well, that's not too big of a deal. First of all, we're gonna have to do a little bit of change here. Okay, but it cannot be coming from the same src anymore. So now we have to say assembly source files will follow this rule. Okay. And then obviously we also need to define those things. So we need to, you know what? I know why we have a problem. We have not defined source. So all along it did not. These includes are doing nothing because source is empty. Okay, fine. It's always the obvious things like, did you plug it in? Okay, so our pointless.c is the only source C source file here. Our only assembly source file is more pointless.uppercase S. Okay, and so now this part should work. But I also need to replicate this rule. Okay, in other words, I need to do the same thing, except this time it applies to .uppercase S.
How do you do that?
5YY and then JJJJJ and then P.
I'll practice.
Okay,
that.
5YY means yank 5 lines, or basically it's copy, right? Copy the current line and then the 4 lines after that as well. So it's going to put that into a clipboard, and then you move the cursor down to where you want to paste, and then lowercase p will paste the content after that line. If you use uppercase p, it will paste before that line.
Okay.
Yep.
This first instance, what are these /M&Ms?
Chocolate. The -mm, is I think it's a macro option. It specifies that it will spew out the dependency list. That's the magic part of this entire thing.
So it spills out GCC specific format dependency list.
Yep.
If you add a D after the MM, it does the exact same thing as your sed stuff.
Oh.
If you do -mmd and include that in every GCC command,
Mhm.
you can get rid of your sed magic there.
Okay, I'll try that. Thank you. It's all in recorded, so I can actually go back.
What is our .d files doing?
The .d files? The .d files are dependency files. In other words, I'm generating components of the makefile based on the source files.
And where are those being stuck into? Because you've already manually defined everything above them.
I'm going to take all those away at some
And
point.
if you take all that away and just include your definitions and that stuff, it will make
Yep.
the same thing.
Yep, exactly.
Oh, that's
So we're going to do this one too. Executable is just pointless. So that means, now I can specify things a little bit differently. We can say $exe colon dollar src colon replace .c with .o, and is that the right format? Yep, it is.
Yeah.
But it doesn't highlight it the same way as the bottom one. That makes me think that maybe I did something wrong. I'll let the make file complain. But we also need a second rule, a second component here, because remember, your executable does not only depend on .c source files, you also have assembly source files. So you have to use both of those to specify the object files that you need in order to create your executable. Is that making any sense? Okay. So that means this one is now useless. Okay, not only is it pointless, it's also useless. Okay? What about this one?
No, you still need
That
that
one
to create
is
the object files.
well, actually, it is pointless too. It is I should say it is useless as well as it is pointless, because this is already specified in one of the .d files. Okay, when we look at pointless.d, it actually says about the same thing. Not exactly the same thing, because it doesn't tell me how to do it. It just says, this depends on that. But it doesn't say, but how do we generate this from that? Well, remember, it has built-in rules to do it. Okay, so we'll just see what the built-in rules are going to do and why it may not be sufficient for our application. So we'll comment out this one, and this one, we can comment out too. But wait. We don't have more pointless.d yet, right? More pointless.d does not exist. It's a new file. Okay. So let's go ahead and make anyway and see what it does. Whoa, it did it, right? Well, let's see what it did, okay? Because we want to find out what it did.
It says
The first thing that it did was to create more pointless.d, the dependency file itself.
Yeah, what about the line right before that?
Yeah, it says no such file or directory, then it did.
Then it did, right. Now the first line complains only because when I say include, I included all those files. So it complains and say that, well, you're trying to include a file that is not existing, but it's only a warning. It didn't really stop the process. It just says it's missing. But then it realized, oh, I have a rule to create that, and that's the rule that creates it. And it also brings pointless.d up to date as well. And then based on those two rules, okay, defined in the two .d files, now it understands how to create the object file from the .c file. The other one I have not changed so that it did not recompile. But now I can actually do it. I can say touch more pointless.inc, the include file, and then when I say make, it also it will go through the whole thing. It recreated the .d file, and then it went ahead to recompile or reassemble the assembly file, and then relink the target. Yep.
So if we had another dependency like pointless to .c.
Correct. Now we have two dependency list files.
Yeah. Like if we had another file we're added to our project and we
Yeah.
add that to the source, it'll generate the rule for it and
Yep.
assemble it, and everything will be
Yep, exactly. So if you want to add, yep, go ahead.
If you want to put a dash before the includes, and if the .d's don't exist, it won't give you the warning.
So put a dash in before the include,
include statement, yeah.
like this?
Yes.
Ooh.
That just hides the warning if it doesn't exist.
I see. Thank you. Very good. All right. Cool.
Alright, now let's delete one of the dependency lists and see if it works.
Delete one of the dependency files.
Yeah,
Correct.
the
See if
.c
anyone
files.
will throw the
Sure.
warning. And I got approved.
Yep. it did not generate the error messages. So suppresses error messages. Yeah, it's like a silencer.
Don't put it for every command though, it'd be a little weird.
Don't you put it
It
before?
works for, you can put it for anything,
Yeah.
but it's probably a bad idea.
Dash that whole thing up.
Dash that whole thing up. No, that's a new phrase. That's a new quotable quote. Dash that whole thing. Yes. Yeah, when someone offends you, now we know how to respond. Dash you. New age cursing. Yep.
Is the make stuff gonna be on the pass?
No, but it will help you.
You have to memorize the set magic.
All right. Now, but let's go back and take a look at what we have at this point. What we have is a kind of flexible scheme where if you have another file that you want to specify as a component of your project, you just have to put it either into the definition of SRC for C source, or put it into ASM SRC for assembly source file. If you have C++ files, all you have to do is to define another one for CPP or C++ SRC, whatever you want to name that thing, and then replicate, add the component here, add another component here, and also add another component here. And then your project will handle, any mixture of these files. You can actually have a project that involves C++, C, assembly, or any other language that can be specified and cross-linked. Okay? And all you have to do when you have the whole thing set up is you only have to change the first few lines of your makefile, and you don't have to change anything else. You can have your include files to pound include, in the nested way, to pound include other things. It will figure it out automatically. Okay, so I think this is really helpful. Okay, a lot of people think, oh, but you're wasting so much time to use all these different things. But in the end, it makes everything much more reliable than it was before. Okay, but we still have a problem. Okay, let's clean up everything. Okay, this is another thing. You can also specify a clean target. So at the end, anywhere you can specify clean, and clean just depends on starter O. Can we use that? I think clean can just be clean because you can just say make clean, so it doesn't need a dependency. Then you can specify everything that you want to delete that is not either the source or that is not a source, basically. Anything that is non-source, you can delete it here. And then we can use the same trick. We can say, take a look at SRC, replace all the .c with .o, and then we can just replicate this a few times. Okay. I'm trying to be lazy here. Just use paste, paste, paste. Okay. ASM, because I can also remove the .d files. Okay, ASM, because with the ASM files, the extension is .s. There you go. All right. So now that we have a clean target, we can say.
Yeah, last one.
Oh.
You have two .os and a .d.
Oh.
Very left.
Go. So when we say, guess we can use a dash to.
Yeah, dash for RM is pretty useful too.
Yep. Or you can use a bracket and say dash E and then do the RM. Yep.
The other thing I want to say is you should make the clean target a phony by doing .phony in all caps and say clean after it. Otherwise, if you have a file with the name clean in the current directory, it'll do nothing. You do make clean.
Ah. Okay, that makes sense. That's a good one. Okay, but now we don't have any of those files anymore. So the principle still works, even though it's not as perfect as it can be. Okay, well, we forgot one thing. We forgot the executable, didn't we? So go here, and then also specify, also remove the executable, because the executable is something that you can regenerate from the source files, and therefore when you clean, you should probably clean that too. All right. Okay, we're still missing certain things, so this is also a good time to look at this again. It did recompile everything correctly, except you cannot GDB it, right? Because we don't see -G anywhere here. When you say GDB points list, and you do a list, it doesn't know anything. Because the debug table or the symbol table for the debugger is no longer here. We didn't specify -g when we compile or assemble. So what you need to do is now to specify, go back to the makefile, and then you need to specify, I think for C compiler, it is C flags. And then for the assembler, it is AS flags. I could be wrong. So we say make it clean again, and then make again. And you can see that this time it includes -G when it compiled the C code, and it includes -G also when it assembled your assembly source file. In other words, the make file or the make utility program actually has some default pound includes or include files or default rules that you don't see. They're all implied. And one of those implied rules is, it's how do you create an object file from a .c file? It already knows how to do it. But when it does it, it doesn't understand what kind of options you want to include. So what you do is you utilize these options here. C flags are the flags that you pass when it compiles a C code, a C source file. AS flags is what it passes when you assemble an assembly file. So once you specify these options, then it understands whenever it compiles a C program, include the -G. If you want to use -wall, you can just include that. You can include whatever you want when it's compiled. So let's go ahead and try this one again. And you can see -wall only applies when it's dealing with .c files, and it does not apply to .s file because it is not a part of AS flags. It's only a part of C flags. Yep.
What is your CXX flags?
That's for C++. So if you have G++, then it knows that it will use those flags for C++ programs.
Okay.
All right. So are there any questions? I mean, I'm done with this file. I mean, it's not as perfect as it can be, but it's functional.
One thing I want to ask. You could put the -mmd and the C flags and AS flags and then comment out the rest of it. Well, below include and do the same.
Okay, say it again.
-mmd all caps in both C flags and AS flags, and you could comment out all your %d stuff and do the same thing.
So specify -mmd,
Correct. Capital D.
capital D.
Yeah.
Specify that one over here too.
Comment out the rest of it. %d, said, all that stuff.
So this stuff can go.
-mmd is what that's doing.
Okay, so we have line 22 here. Substitute beginning of the line with comment symbol. Very good. Now touch. H. Again. So it just automatically does it. Figure out.
If you look, it makes the same .d file.
Huh. Very nice.
Pretty cool. Copy.
But you still need the include of the .d files.
Correct. You still need to include them. Yes.
Yeah. Okay, very good. Because what this one does is when you generate the .o file, it will also automatically regenerate the .d files.
Correct.
I'm just trying to think of, okay, let's take a look at the .d file and see what it looks like. It's not going to be it's not exactly the same as
Not exactly
before
the same.
because the .d itself is not a part of it. Okay. All right. So now we have a new and improved version of the makefile, that works, with very little error messages, and it works well.
Now we just need to remind you to upload.
Come on, freeze the screen and copy. Organic copy and paste. Oh.
Really gonna get through that?
Come on, guys. This is already done. Remember, everything that's commented out, you don't have to type.
So let's see. 1, 2. All right.
All right.
6, 7. Oh, we only have to type 9.
That's so many
How's that?
I like it.
Beautiful.
I mean, my 6th grader will say that, Dad, I'm gonna need about 5 minutes to type this. Okay, but how about you guys? So I don't think it's too bad. I mean, this is not bad at all. And the best thing is, it works not only for your assembly language class, it also works for your other classes too. How many people still use an IDE? Integrated Development Environment for your C++ class or your, object-oriented programming class.
Yes, it's
With this,
using
you don't
right
need
now.
an IDE anymore. All you need is make, G++, and GDB.
But this doesn't apply for Linux.
No, it works in Linux too. I mean, it works in Windows too.
Same file?
The entire tool chain. The whole tool chain is ported to Windows. So you can now do everything inside the CMD command line. Yeah.
Different commands for Windows, but like the command line files.
No. The entire tool chain is ported. So it is, G++ is the same. It's GDB the same.
Yeah.
It's
to
cross
get to the directory, you use different commands or something like that.
Sorry?
Like you wouldn't use.
Well, there is one thing there's one thing to watch out for if you want to do this in Windows. The only thing you have to watch out for is Windows is case insensitive. In other words, in Linux, you can, if you want to have f.lowercase s as a file, and then you can also have one file called f.uppercase s file. Okay, both files can exist at the same time because the file names are case sensitive. That does not happen when you have Windows. It is case insensitive. So if you rely on the sensitivity of the case of a file name, those tricks won't work in Windows. I tried already, so Yep.
Is this homework assignment due Tuesday or Thursday?
It's due 1 week from today, but I think you can get it done in 15 minutes.
Yeah. Wow. You're
All
giving
right.
me a lot of credit.
Yeah.
But thank you.
I'll see you guys next Tuesday, and go ahead and make sure you study up,
I know. No, you're probably right.